So in today's class, we are going to talk about two things primarily. One is the means, okay, and the other is the series, okay. So under means, we are going to study three types of means. One is arithmetic mean. So I'll start with arithmetic mean. Arithmetic mean. So we'll be talking about geometric mean, harmonic mean as well. So what is an arithmetic mean? Let us understand that first. So when it comes to arithmetic mean or geometric mean or harmonic mean, we talk about two types of means, or we talk about two phrases. One is arithmetic mean of certain numbers. So I'll write it down. Number one, we talk about arithmetic mean of certain quantities, A1, A2, etc. Okay. So arithmetic mean of these quantities is basically nothing but it's the sum of these quantities divided by the total number of quantities. The same way as you find the mean in your statistics. So when you divide this whole thing by n, it gives you the arithmetic mean of. The word here is of. What is the word? Of. Arithmetic mean of these quantities. But we are going to talk more about inserting arithmetic means between two numbers. So the next concept that we are going to talk about is insertion of arithmetic means between two numbers. Between two numbers. This concept is more important to us. This concept is more important to us. So here we are going to learn how to insert 1, 2, 3, 4 or n number of arithmetic means between two numbers. So these two numbers will be given to you and the question setter will ask you to insert, let's say 5 arithmetic means or 10 arithmetic means or whatever. Okay, depends upon the question setter. So this part is of importance to us because the first part is already done in statistics. Nobody is going to bother asking you these questions. So if let's say A and B are two real quantities and you want to insert one arithmetic mean between them. So first of all, what is the meaning of inserting one arithmetic mean between them? All of you please pay attention. Inserting an arithmetic mean between two numbers is like saying that these three come in arithmetic progression. Okay? These three numbers come in an arithmetic progression. Understood? So inserting arithmetic mean between A and B is basically finding a quantity A1 such that A, A1 and B are in arithmetic progression. So this is very easy to find out. You will say that, okay, to find A1, I can use the formula that twice of the middle term is sum of the first and the last term. So that gives you the value of A1 in terms of A and B, small a and B, right? So this is your arithmetic mean between A and B. And coincidentally, this is also the arithmetic mean of A and B. So it is satisfying both the criteria. So A1 is not only the arithmetic mean between A and B, it is also the arithmetic mean of A and B. Okay. Any questions in inserting one arithmetic mean between A and B? Do let me know. Do let me know. Okay. People have joined in. Very good. Good afternoon to everybody. Okay. All right. So let us extend this concept. Let us extend this concept. If I ask you to insert two arithmetic means between A and B. So A and B are given quantities and I am asking you to insert two arithmetic means between A and B. Again, what does it mean? It means that you want to find out A1 and A2 in terms of A and B in such a way that these four numbers are in AP. So how do you find that out? So very simple. If they are in AP, you can say let the common difference be D. So A1 is A plus D, A2 will be A plus 2D, and B will be A plus 3D. Right? So from this we can say your D is nothing but B minus A by 3. Okay, start putting it in the A1 and A2 expressions. So your A1 will come out to be A plus B minus A by 3, which on further simplification, let me move my camera, which on further simplification gives you 2A plus B by 3. Okay. Similarly, your A2 will be nothing but A plus twice of B minus A by 3, which on further simplification gives you A plus 2B by 3. Is it fine? Any questions? Any questions? So A1 and A2 are these two arithmetic means between A and B. Any questions? Now, has anybody started observing the pattern? The pattern as to, if I ask you to insert any number of means, you will be able to do it by the observation of that pattern. Has anybody seen the pattern here so far? Only 2 instances I have given, but I want to see if somebody is smart enough or quick enough to recognize the pattern. Okay, so Pranav has recognized the pattern. So this is a question to Pranav. So Pranav, let's say between A and B, I'm inserting 3 arithmetic means, A1, A2, and A3. Okay. Now, without doing anything, let me write this as second case. Yeah, third case. Yeah. Without doing anything, can you give me the value of A1, A2, A3 directly? What is A1, A2, A3? Dida, I don't want. I want, have you observed a pattern on which you can write your AIs immediately? Of course, I know you know the approach. Approach is very well known to you. Have you noted down the pattern in which these guys are written? Anything that can help you to write them directly? That is what I'm asking. Okay. All right. I think we have to wait for one more instant for you to observe the pattern. Okay. Never mind. We'll take one more instance. It's better to delay the process. Okay. And understand it properly. So let's say D is the common difference. So A is small a plus D. A2 is small a plus 2D. A3 is small a plus 3D. And small b is a plus 4D. Okay. So from here, I can say D is B minus a by 4. Start putting it over here. So if you put it there, your A1 becomes a plus B minus a by 4, which is nothing but 3a plus b by 4. Okay. If you put this over here, you end up getting A1 as a plus twice of b minus a by 4. But actually, I will not cancel out 2 and 4. I'll keep it as it is. Okay. And when you put it over here, I'm sorry, A2. Yeah. And I put it over here, I get a plus 3 times b minus a by 4, which is nothing but a plus 3b by 4. Do you see a pattern, or still you can't see it? Pattern diste katula. Can you see the pattern? I just spoke in Marathi. It is like binomial. Okay, very good. Yes, yes, yes. Okay, now what you would observe that, see, if you're putting 3 arithmetic means, okay, this number will be 1 more than that, for sure. Yes or no? If you're putting 2 arithmetic mean, it will be 1 more than 2, which is 3, 3. So as you can see in your denominators, okay. So if I'm putting n arithmetic means, the denominator number will be n plus 1. That is for sure, right? And if you're putting 3 arithmetic mean, you have to multiply 3 with a first. Okay, keep b as 1, and slowly a starts giving its coefficient to b, just like it happened in binomial, right? So from 3 it became 2, and from 1 this guy became 2. Now from 2 it became 1, and from 2 this became 3. So a starts sharing its coefficient with b. Correct? This is the pattern that you need to remember. So if you know this pattern, you'll be able to extend this to any number of arithmetic means. So let's say if I take the fourth case, so between A and B, I want to insert 4 arithmetic means. A1, A2, A3, and A4. What will be these values? What will be A1? A1, quick. 4A plus B by 4 plus 1. See, without using anything, I'll write it down. A2 will be 3A plus 2B by 4 plus 1. A3 will be 2A plus 3B by 5. A4 will be A plus 4B by 5. Is this fine? Understood? Any questions? Very good. Excellent. I think most of you have understood the process. Now we'll generalize this. I hope you have copied this down. Nobody is Copying it again, now. All done with the copying part? Done? Done. Okay, beautiful. All right. So in general, if between two numbers A and B, I'm inserting n arithmetic means, capital A1, capital A2, till AK, till AN. Okay. Why I wrote AK in between? Some kth mean, just to know the value of that kth mean. So what will be A1? We all know A1 will be NA plus B by N plus 1. Okay. What will be A2? N minus 1A plus 2B by N plus 1. What will be A3? N minus 2A plus 3B by N plus 1. Okay. Sorry for the bad handwriting here. So if I go on till AK, what will be AK? Okay. What will be AK? Can anybody tell me what will be AK? Feel free to write it on the chat box. Bega. AK. Initials of my name, AK. अरे बताओ यार. No, Himanshu. Correct, Aditya. So it will be n minus k plus a, n minus k plus 1a plus kb by n plus 1. Okay. Yes, Shreyas, that is also acceptable. So an finally would be a plus nb by n plus 1. Any questions, any concerns, please do let me know. Okay. Now, before we move on to problem, a very important result I would like to share with you, because this result has been asked a lot of times in competitive exams. If between A and B you are inserting n arithmetic means, आपको जान के ये खुशी होगी that the sum of these n arithmetic means is nothing but n times the arithmetic mean of A and B. Okay, so please remember this result. Of course, you can always find it out. It's very simple to derive it. So it is always n times the arithmetic mean of A and B. Okay. Very important result. It is asked in many competitive exams. If you're wondering how, then start adding these terms. You will realize that if you take n plus 1 out common, the coefficients of A will be 1 plus 2 plus 3 all the way till n. Similarly, coefficients of B will be also 1 plus 2 plus 3 till n. You can easily find that out, and the answer will become n A plus B by 2. Okay. If you want, I can do it very, very quickly over here. The proof is, we take 1 by n plus 1 out. So it will be n plus n minus 1 all the way till 1 times A, and again 1 plus 2 plus 3 all the way till nb. Okay, so we all know that this guy is going to be n plus 1 by 2. Okay, and this guy is also n into n plus 1 by 2b. Okay, this n plus 1 cancels out with this guy. Take n by 2 out, or take n out, it will be a plus b by 2. That is nothing but n times the arithmetic mean of A and B. Is this fine? Any questions? Any questions? Any concerns? Okay, let's move on to questions. Let's move on to questions. Where are my questions? Where are my questions? Okay, let's take this one. Okay. Between 1 and 31 are inserted m arithmetic means. Between 1 and 31, m arithmetic means are inserted, so that the ratio of the 7th and the m minus 1th means is 5:9. Find the value of m. Find the value of m. Let's do this problem. Put your response on the chat box. Give me a response on the chat box. Done? Anybody? Very good, Gayatri. Very good. Okay. So between 1 and 31, you are inserting 1, 2, 3, till AM. M arithmetic means are inserted. Okay. So what is given to us is that the ratio of the seventh to the m minus 1th arithmetic mean is 5:9, right? By the way, what is your 7th arithmetic mean? 7 arithmetic mean will be m minus 7 plus 1, which is m minus 6 times a plus 7 times 31 divided by m minus 1th would be 2 into 1 plus, by the way, m plus 1 I'm cancelling off. I'm not writing it out. Okay, but if you want, I can do it. Let me do that if you want me to. Divided by m plus 1. Okay, and this whole thing is divided by 2 into 1 plus m minus 1 into 31 by m plus 1. So this is given as 5:9. Okay, so m plus 1 will get cancelled off. On simplification, your numerator will give you m, this is 217. 217 minus 6 is 211. Okay, and down here I'll get 31m minus 29. Okay, this is 5:9. Cross multiply. So 9m plus 1899 is equal to 155m minus 145. Okay, so this will give you 146m is equal to 14, 1. How much it comes out? 420. Okay, so m will be nothing but 2044 upon 146. I think this is 1022 by 73. It'll go by a factor of 1 and 14. Yes, so m is 14. How many of you got this? How many of you got this? Excellent, Prateek. Good, Advik. Good, Anurag. Yes, Pranav, you have any question? Okay. Okay. All right. So now, without much waste of time, we'll talk about geometric mean. Geometric mean. So just like we talked about two types of means, in fact, it's not two types of team, it's like two types of questions that are asked with respect to them. So first type of question would be like finding the geometric mean of, okay, of certain quantities, A1, A2, A3, etc. till An. Okay. Now, when we talk about geometric mean of these quantities, we normally take them as positive quantities. So geometric mean of these quantities is defined as the product of these quantities raised to the power of 1 by n. Okay. So nth root of the product of these quantities. And we normally keep these quantities positive. Now, what is the reason for keeping it positive? See, this entire thing started with the fact that when we talk about arithmetic mean of two quantities, right? So if you use this formula, let's say I say geometric mean of A and B. So as per this formula, it should be AB under root, isn't it? Correct. Now, means are normally of the same nature as the numbers involved. So if the numbers are of different nature, okay, what will happen is that the mean will be an incorrect if, let's say, A and B both are negative. Correct. So what will happen? Your answer will become, let's say I take an example. Let A be -4 and B be -9. Okay. If you use this formula, your geometric mean will come out to be under root of -4 into -9, which is actually 6. How can a mean is something which is supposed to be between the numbers, right? How can mean be positive when the numbers themselves are negative? See, again, don't go by the definition of the fact that it should be in GP, right? I agree, -4, 6 and -9 can be in GP. That is fine. But that is not how means are defined. Okay, means are normally used in physics to basically denote something which is somewhere in between the numbers. Not exactly midway, somewhere in between the numbers. So how can +6 come between -4 and -9? Are you getting my point? So in such cases, this formula is not going to work. That means this formula is not going to work if these numbers are negative, or let's say if some of them are positive negative, right? That is why this constraint has been imposed, that when we are talking about geometric mean of positive numbers, then only we'll use this expression. So let's say if I wanted to find out the geometric mean of -4 and -9, this would not be applied. So what will be applied? Minus under root AB. That means your answer should be -6. This is acceptable. Are you getting my point? Okay. So this is the reason why when we are talking about finding the geometric mean of n numbers, we prefer or we take them as positive quantities. Okay. Anyways, the next concept that we are going to talk about is insertion of geometric mean. That is more important to us. Insertion of geometric means between A and B. Okay. So let us say I start with a very simple case. A and B, okay, let's say A and B are positive numbers. Okay, I don't want to take them as negative, because let's talk about positive only. And you will be only asked question when the quantities are positive. So let's say A and B are positive real numbers, and I want to insert one geometric mean between them, right? Now, what I said earlier for arithmetic means, that is also true here, but not literally. So these three should be in geometric progression, but G1 should be such that it is supposed to be between the numbers. Now, one small thing that I would like to highlight over here, if A and B are positive, okay, your G1 square, okay, or you can say, let us say G1 by A is equal to B by G1, okay. So G1 square will be equal to AB, which will result into two answers. One is plus under root AB, and other would be minus under root AB. Let me write it like this. Other would be minus under root AB. Please note that this will be rejected if your quantities A and B are positive. So please note that if they are positive, this will be rejected. Okay. When will this be accepted? This will be accepted when your A and B were negative quantities. Had A and B both been negative quantities, just like the example I gave a little while ago, -4 and -9. If A and B will be negative, then the geometric mean will be minus under root AB. Now I know what question is running in your mind. What if they are of opposite sides? Isn't it? Is that question running in your mind? So if A and B are of opposite sign, okay, please note that the geometric mean is not defined. Right? The reason being, the answer for the geometric mean here would be a imaginary number. As I told you, means are supposed to be something between the number, right? So when we talk about real quantities, I want a real quantity which is between the numbers. I cannot have an imaginary quantity between the two numbers and I claim it to be the geometric mean. Are you getting my point? So it should be of the same, you can say, characteristic as A and B is, right? Because these guys, they basically replace, or they are basically representatives of that group of number, right? Many times we replace something by the mean, right? So a mean, for example, you must be talking about center of mass, right? Center of mass is what? Center of mass is nothing but it is a type of a mean. It is a weighted average, right? So what all the particles, right, do, that mean will be a representative of that particle. Okay, that is why we say for quantities when A and B are of opposite sign, the geometric mean is not defined. If A and B are both negative, geometric mean is minus under root AB. So if A and B are positive, then only the geometric mean will be plus under root AB. So since I've already claimed in my discussion that A and B would be positive, so I'll be only accepting this result, okay, and not the others. Make sense? No, how? -4 and -9, does an imaginary quantity come in between somewhere? I don't think so, Aditya. And if you're representing a mean of real numbers by an imaginary quantity, right? They're two different natures of the numbers, right? Means are basically used to represent a sample set, characteristic of a sample set, mean age of the people living in the society, correct? Mean distance of, between the galaxies. How can it be, completely, of a different nature than the quantities themselves? That is the main reason, as a convention, we do not use, or you do not find out the means of these quantities when the quantities are of opposite sign. Getting my point here? Okay, I understand many of you would be reasoning it out from your GP point of view, but as I told you, it is in GP, but do not, directly use that concept only. Okay, now here this quantity G1, we have already figured it out. I will prefer to write it as a to the power half, b to the power half. Okay, so that we can see a pattern little later on. Okay, let's take the next instance. If between A and B, which are positive quantities, I am inserting two geometric means G1 and G2. Okay, let me know what is G1 and G2 in terms of A and B. What is G1 and G2 in terms of A and B? Now, here also, let's say I assume that if these are in, if A, G1, G2, B, G1 and G2 are the geometric means, that means these three quantities are in GP. Okay, and I'm already assuming A and B are positive quantities. I'm not going to write it again and again. Okay, so first of all, G1 is AR, G2 is AR square, and B is AR cube. So your R could be written as B by A to the power of 1/3. Okay, so now when you put it over here, your G1 becomes A, B by A to the power of 1/3 will give you A to the power 2/3, B to the power 1/3. Observation, guys, I would like you to be very, very careful in figuring out what is the observation here. Okay. Can anybody observe the pattern? Pattern. Pattern. Yes, Gayatri observed the pattern. Very good, Gayatri. Now, if you try to connect this with the arithmetic means, you will realize that what used to be the coefficient of A is now the power of A. What used to be the coefficient of B in case of AMs, now here it has become the power of B. Do you see that? Okay. If you recall, what was your A1? A1 was 2A plus B by 3, right? So write it like this, right? So if you see this power, this term has now become the power over here. Okay. And this term has now become the power of this guy. Do you recall? Okay. So if you have understood this pattern, you will be able to write down, even if I am inserting any number of geometric means, let's say between A and B, I am inserting 3 geometric means, G1, G2, G3. Okay. Now without solving it, let's try to write that the values of G1, G2, G3 down. So G1 will be nothing but, tell me, A to the power of 3 by 4, B to the power of 1 by 4. Very good. G2, A to the power of 2 by 4, B to the power 2 by 4. You can write half also, but I just wanted to make the pattern more explicit. And finally, A to the power 1 by 4, B to the power 3 by 4. Okay. If you observe this pattern, we can basically write down, even if you are inserting any number of geometric means. Correct? Any kasta here, any problem here, please immediately bring it to my notice. A1 is log G1. Not exactly, Aditya, but if you take a log, that then log A will come now into picture. 3 by 4 will come down, but log will come into picture. Okay. Yeah, kind of. This is good for you to remember in that way, but yes, not exactly. Not exactly. Yeah. So let us generalize this. So in general, if between A and B you are inserting, let's say n geometric means, then your G1 will be nothing but A to the power n by n plus 1, B to the power 1 by n plus 1. G2 will be A to the power n minus 1 by n plus 1. This will be 2 by n plus 1. Gk will be A to the power n minus k plus 1 by n plus 1, B to the power k by n plus 1. And basically finally your Gn will be A to the power 1 by n plus 1, B to the power A to the power 1 by n plus 1 and B to the power n by n plus 1. Okay. One important result, just like I shared with you one result in arithmetic means, very important result that I would like to share with you. One important result is the product of the geometric means that you are inserting between any two numbers A and B is nothing but it is the geometric mean of A and B raised to the power of n. In other words, it is AB to the power of n by 2. Please remember this result. So the product of all the geometric means that you are inserting between A and B is nothing but the geometric mean of A and B raised to the power of n, or you can say AB to the power n by 2. Okay. This is asked as a direct question in many competitive exams. So please note this down. Okay. Yes, somebody has a question. 1 second, copying. Okay, copy. Let me know, Anurag, once you're done. We are all waiting for you. Don't worry about that, Himanshu. Just understand that if the geometric mean is asked for two numbers which are negatives, just put a minus under root AB. Okay. And nobody is going to ask you the geometric means for negative numbers. Don't break your head on it. Okay. We'll be only talking about geometric mean and harmonic mean of positive numbers only. Arithmetic mean can be positive, negative, both. All right. Let's move to some questions. कुछ सवाल करते हैं. Let's do some questions. I forgot to give you this question. Okay, let's take this question. Sorry for giving you an AM question while doing GM. I forgot about this question. This is an important question for school level also. And let's solve this. Find n such that a to the power n plus 1, b to the power n plus 1 by a to the power n plus b to the power n be the arithmetic mean of a and b. Now, some of you would have started guessing the values also. Okay, I would request you to do it in a proper way. Proper way means the actual way how you would do it in your school exams. Correct, Advik? Absolutely. Correct, Aritra. Correct, Anurag. Yes, 1 a.m. only. 1 a.m. between A and B. Absolutely. Okay. So since most of you have done it without wasting much time, because you have to cover a lot of ground today, so you must be observing that I am writing also very fast. So arithmetic mean between A and B will be A plus B by 2. Okay, let's cross multiply. So 2an plus b to bn plus 1 is equal to a plus b times a to the power n plus b to the power n. Okay. If you open the right hand side, you'll end up getting a n plus 1, b n plus 1, a b to the power n, a to the power nb. So one of these will get cancelled off with this. So I'll just scrap off the coefficients. Okay. Let us bring this term to the other side and this term to the other side. Okay. So a to the power n plus 1 minus a to the power nb is equal to b to the power a b to the power n minus b to the power n plus 1. Take a to the power n common, you'll get a minus b. Take b to the power n common, you get a minus b. Now remember, the question says at one place that a is not equal to b. Do you see this? It says a is not equal to b. So if a is not equal to b, it implies that a minus b cannot be 0. And if something is not 0, you can easily cancel it off from both the places. Okay. So this leaves you with a to the power n equal to b to the power n, or in other words, a by b to the power n is 1, right? So this means either a by b is 1 or n is 0. But if this is 1, means you're saying a equal to b, which is not possible. Okay. So the only possibility left is n is 0. So yes, absolutely correct. Janta, who said n equal to 0? Absolutely right. Sir, how is it in AP if n is equal to 0? A, if n is equal to 0, it becomes a to the power 1, b to the power 1 by 2, and b. Isn't this in AP? Aritra, answer yourself. Yes, it was guessable also, Hariharan, but I basically solved it from your school points of view also. Okay. All right. So let's move on. Can I move on to the next slide? Anybody who's busy copying this? Done? All right. Okay, a similar question, exactly the same question, but now this time This quantity is the geometric mean between A and B. This quantity is the geometric mean between A and B. What is the value of n? What is the value of n? Okay, any response? All right, so in the interest of time, guys, we will be slightly fast. Very good, absolutely. So people who are answering with minus half, you are absolutely correct. Okay, again, let's cross multiply. So a to the power n plus 1, b to the power n plus 1. Okay, and if you multiply, you get a to the power n plus half, b to the power half, and this will give you a to the power half, b to the power n plus half. Okay, let's take this on the other side. Let's take this on the other side. Okay, so this will give you a to the power n plus 1 minus a to the power n plus half, b to the power half. And if you take on this side, we have a to the power half, b to the power n plus half minus b to the power n plus 1. Take a to the power n plus half common. So this will give you a to the power half minus b to the power half. And take here b to the power n plus half common. A to the power half minus b to the power half. Now remember, a and b are not equal. So if a and b are not equal, means these two terms cannot be zero. In fact, I can say this is cannot be zero. So this can be cancelled off. Okay, giving you a by b to the power n plus half as 1. So this can happen only when a by b is 1 or n plus half is a 0. But this is not possible. This is not possible because a and b are not equal. So it is only possible when n is minus half. Okay, so please keep this in mind. Many times the local competitive exams like CET, Comet K, VIT, PaySat, they ask these questions directly, right? And if you, I mean, there is actually a pattern in these values. We are going to do the very same question for harmonic mean also. And you'll see that there's a pattern in the values of n. So if you remember it, again, I'm not endorsing you to remember things. If you, happen to remember it, you can save a lot of your time in the examination hall. Okay. Oh, Hariharan got stuck. Is it fine? Any questions? Any questions? Any concerns? Can we move on to the next? All right. So let's take very simple question. If A be 1 am and G1 and G2 be two geometric means between B and C, then prove that G1 cube plus G2 cube is equal to 2ABC. I would request everybody to just write done. Okay. Just write done once you are done with this problem so that we can discuss it. Done, done, done. Anybody? Done. Very good. All right. So let's have the numbers B and C. A is one arithmetic mean between B and C. So A is an arithmetic mean between B and C. So we all know that 2A will be equal to B plus C. Let's call it as number 1. Okay. And we have also been provided that between B and C, there are two geometric means also inserted, G1 and G2. G1 we already know is b to the power 2 by 3, c to the power 1 by 3. G2 is b to the power 1 by 3, c to the power 2 by 3. Correct? So G1 cube will be b square c. G2 cube will be b c square. Correct? So from your given expression left hand side, G1 cube, G2 cube. Okay, we will have b square c, bc square. Take bc common, you will have b plus c, and b plus c is nothing but 2a. And there you go. That proves the result, which is your RHS. Is it fine? Any questions? Any questions? Any concerns? Easy? This could be a question in your school exam as well. Can I go to the next slide? Can I go to the next slide? All right. This is a slightly distorted looking question, but I hope you can read this out. The arithmetic mean between two numbers whose sum is 100 is to the geometric mean is 5:4. Let's read it again. Arithmetic mean between two numbers, comma, whose sum is 100 is to the geometric mean as 5:4. So AM is to GM is 5:4. Okay. And the numbers whose AM and GM you're looking for, and the numbers whose AM and GM you're looking for, the number's sum is given to us as 100. Okay. Find the numbers. Find the numbers. Good, Pranav. Awesome. Okay. Very good, Aditya. Very good, Aditya. Okay, before we proceed, guys and girls, I would like to discuss a brief theory related to it. Okay. If you know that the arithmetic mean of two numbers is A and geometric mean of those same two numbers is G, then remember A and B will be roots of this quadratic equation, x square minus 2ax plus g square equal to 0. Now, how? Why? Okay. If a and b are roots of any quadratic equation, we know that the quadratic equation can be written like this. Correct? We all know that it is actually x square minus a plus bx plus ab. Okay. So from here I can say a plus b is actually 2a. And from here I can say ab is equal to g square. So if you put it over here, you get minus 2ax plus g square equal to 0. Right? Sometimes this question is also directly asked in many competitive exams, right? Now, let us use this result over here. So first of all, your AM is nothing but A plus B by 2, which is itself 50, correct? And since AM is to GM is 5:4, it implies GM has to be 40. Okay. So now, basically, your A and B will be roots of this equation, which is A square minus 100x plus 40 square. Correct. Now, some people also find this result and keep it because it can be very, very useful sometimes. So minus B plus minus B square minus 4AC by 2A, which is nothing but A plus minus under root A square minus G square. So here also I can find out your roots as 100 plus minus yeah, B square, A square is 50 square minus G square is 40 square. So this is 100 plus minus, I think this will be 900, correct? Oh, I'm so sorry, A. Instead of A, I wrote a 2A, my bad, okay? So this will result into two things, one is 80 and other is 20. So you don't know which one will be A, which one will be B. So any one of them can be A. So this could be A, okay, or this could be B, or this could be B, this could be A, okay? So your A and B, the numbers are 80-20 or 20-80, doesn't make a difference. Answer will be the same. Any questions here? Could you explain the quadratic part? See, if you know the arithmetic mean of two numbers and you know the geometric mean of two numbers, then the two numbers will actually act like the roots of this equation. Why? The proof of this I have already given over here. So if A and B are roots of any quadratic, basically that quadratic should have factors as x minus A and x minus B, correct? So this quadratic will be formed, correct? Here if you see A plus B term is nothing but 2A. That's what I have written over here. A plus B is 2A. And AB is G square, correct? So this quadratic, if you find out the roots by using your Sridhar Acharya formula, it is going to be minus B plus minus B square minus 4AC by 2A. So as per that, this comes out. So this formula is known to many of the students. And if you know it, you can easily come to the final answer. Now, I'm not saying that you have to follow this to solve the question. No. But this gave me an opportunity to discuss a theory with you, which may be helpful in your problem solving. I'm sure most of you would have solved it without knowing this also. That is absolutely possible. Is it fine? There is one person who has joined in now. Can you just ping me on the chat box if you have joined in now, because you lose out on the attendance. The attendance was already taken long back. Okay, fine. May I know the reason for you joining so late? Slept off Saturday afternoon. Okay. All right. So yes. So time to take harmonic mean. Harmonic mean. Now harmonic mean of the word of certain numbers. Okay. Again, for the purpose of explanation, please remember these quantities again will be taken as positive quantities. So harmonic mean of these numbers are basically nothing but n by reciprocal sum of the reciprocals of these numbers. So this is how the harmonic mean of n numbers is defined. Okay. Now many people ask me why positive. See, if these numbers are a mix of positive negative, there may be a chance that you may end up getting a quantity which is beyond those numbers. So there will be always a confusion. you will not be able to describe the sample set by that harmonic mean. Second thing is that you may end up getting a 0 also sometimes, okay, in the denominator, which will make the whole thing undefined. That's why if you refer to many books, you can check your Arihant publishers or you can check your Cengage publishers. They will always talk about harmonic mean for positive quantities. Anyway, this is not going to be of that much help to us. We are going to directly talk about insertion of harmonic means between two numbers. Insertion of harmonic mean between two numbers. Okay. Let's say A and B. I want to insert one harmonic mean between these numbers. So what is the value of H1 in terms of A and B? Now you don't have to reinvent the wheel. So you basically have to realize that these three things should be in HP. That is 1 by A, 1 by H1 and 1 by B will be in AP. Are you getting my point? Okay. And 1 by H1 will act like the arithmetic mean of 1 by A and 1 by B. So 1 by H1 will act like the arithmetic mean between 1 by A and 1 by B. Are you getting my point over here? So I can say 1 by H1 is half of 1 by A plus 1 by B. Okay. You may also write this half in a very strategic way, this by 2. Okay. So from here we can claim that our H1 is 2 divided by 1 by A plus 1 by B. Okay. So this H1 value will be nothing but this expression. Guys, it's all about a game of pattern observation. It's all about a game of pattern observation. Just try to link it with whatever you have studied for AM. You'll be able to get to these answers pretty quickly. Okay. If the pattern is still not clear, we'll take one more example. If let's say between A and B, you are inserting two harmonic means, H1 and H2. Okay. How will you find it out? So again, treat this question as if you are treating the reciprocal of these terms. Let me write it in yellow only. Yeah, yellow. In AP. And just recall, in your mind, just recall how you used to find out the first arithmetic mean. First arithmetic mean used to be 2 times the first number plus 1 time the second number by 3. Isn't it? So this itself gives you the answer, which is nothing but 3 divided by 2 by A plus 1 by B. Again, look at the pattern. Pattern is very important. Okay. And 1 by H2 used to be 1 by A plus 2 by B whole divided by 3, which means H2 is 3 upon 1 by A plus 2 by B. Right? Has anybody started noticing the pattern? What is the pattern? Yes, people have started noticing the pattern. Very good, Gayatri. So if you have started noticing the pattern, let us try to answer this question. Between A and B, I am inserting H1, H2, S3 as the harmonic mean. So what is H1? You will say 4 upon 3 by A plus 1 by B. H2 will be 4 upon 2 by A plus 2 by B. And H3 will be 4 upon 1 by A plus 3 by B. Is it fine? Are you happy with this? Yes? Okay. So in general, absolutely, Pranav, absolutely. In general, if you are inserting n, n harmonic means between A and B, remember your H1 will be n plus 1 by n by A, 1 by B. H2 will be n plus 1, n minus 1 by A plus 2 by B, da 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 da, till HK will be n plus 1 by n minus k plus 1 by a plus k by b, and your hn will be n plus 1 by 1 by a plus n by b. Is that fine? Okay. One quick result I would like to share with you, just like I shared it with you for AM and GM. So very important result. The result is the sum of the harmonic means reciprocal is nothing but n by the harmonic mean of A and B. That is nothing but n divided by, what is the harmonic mean of A and B? Harmonic mean of A and B is nothing but 2AB by A plus B. So A plus B will go up. Okay. Please try proving it for homework. Okay. Prove it for homework. Very, very easy way. You just have to reciprocate these results that you have seen over here and start adding it. So n plus 1 will be like 1 by n plus 1 will come, and then you will have 1 by a added to multiplied to 1 plus 2 plus 3 till n. Similarly, 1 by b multiplied to 1 plus 2 plus 3 plus n. Use your sum of natural numbers from 1 to n. You will get this result very, very easily. Okay, better to remember it like this. This is more convenient for us to remember. Is it fine? Any questions? Okay, the same question that we had taken for AM and GM, we are now going to do it for HM. Find n such that a to the power n plus 1 plus b to the power n plus 1 by a to the power n plus b to the power n is the harmonic mean between a and b. Absolutely, Pranav. Very good, Aditya. All right, let's discuss this. So first of all, what will be the harmonic mean of A and B? We have already studied it will be nothing but 2 by 1 by A plus 1 by B, which is actually 2AB by A plus B. Okay, let's cross multiply. So A plus B times A to the power n plus 1, B to the power n plus 1 is equal to 2AB A to the power n plus B to the power n. Okay, if you expand it, it becomes A to the power n plus 2, B to the power n plus 2 plus A B to the power n plus 1 and A n plus 1 B. Okay, on this side, we will have A to the power n plus 1 B and A B to the power n plus 1. Okay, correct me if I'm wrong. So now this term gets cancelled with one of these terms and this term gets cancelled with one of these terms. Okay, so let's bring this term to this side and let's bring this term to the other side. So a to the power n plus 2 minus a to the power n plus 1 b is a b to the power n plus 1 minus b to the power n plus 2. Correct? Take a to the power n plus 1 common, it will give you a minus b. Take b to the power n plus 1 common, it will give you a minus b. And now since a minus b is not equal to 0, you can cancel this off, giving you a by b to the power n plus 1 as 1, which implies either a by b could be 1, but this is not possible. Okay, because a is not equal to b. Or you can have n plus 1 equal to 0, which means n could be minus 1. So as you can see, there's a pattern in these numbers. So just recall when we did AM, n was 0. Then it became minus half for GM. Now it has become minus 1. So you can say that it is actually following a AP in itself, arithmetic progression in itself, isn't it? So 0, minus half, minus 1. So this basically rings a bell when you are trying to solve this question in the examination room. So if you remember it, if you happen to remember it, you can save easily around 2 to 3 minutes. Any questions? Any questions? Any concerns? Let's take another question. Okay, let's take this question. Insert 6 harmonic means between 3 and 6 by 23. I think we never took a question on inserting some means between the numbers. Now I think we are actually applying those concepts. So insert six harmonic means between 3 and 6 by 23. Just say done. You don't have to type it out, please. Don't take that effort of typing your answer. If you're done, just write done. Okay, Anurag says done. Very good. How about others? Done, Gayatri. Very good. So just find H1. Okay, as per the formula, H1 is the total number of means plus 1 divided by n 1 by a. So 6 into 1 by a plus 1 into 23 by 6. Okay, so this gives you 7 by 2 plus 23 by 6. Right? That is nothing but 6 into 7 by 35, which is 6 by 5. Okay. Now, don't start applying formula for others. Just realize if had you reciprocated these two guys, okay, what would be the common difference? Because then these fellows will be in AP. These fellows, they will be in AP, isn't it? So by finding these two, you know the common difference. In fact, you could have found the common difference by using the 1/3 and 3 by 23 by 6 also. But again, if you have found this out, so just figure out what is the common difference. The common difference will be 5 by 6 minus 1 by 3. Okay, how much is this? This is half. Correct? So keep adding half to the answer. So 1/3, when you added half, you got 5 by 6. Okay, treat this as 3 by 6. Okay, again add a 3 by 6, you'll get 8 by 6. Okay, 11 by 6, 14 by 6, 17 by 6, 21 by 6, and finally you will have your 23 by, oh sorry, this is 20 by 6. 20 by 6 and finally 23 by 6, correct? Yes or no? Right? And now just reciprocate it. So your terms will be 6 by 5, that we have already figured out. 6 by 8, 6 by 8 you can write 3 by 4, 6 by 11, 7 by 3 reciprocal is 3 by 7, 6 by 17, 3 by 10, and that term is already given to you, 6 by 23. So these will be your 6 harmonic means. Okay. So having found out the common difference, don't start applying formula for each one of them. It will waste a lot of your time. Is it fine? Any questions? All right. So with this, we are going to now go to a very, very important concept, which is the AM, GM, HM inequality. Very, very important concept. I think a lot of concepts are linked to it. In fact, we had also used it in our properties of triangles chapter, right? So some important properties under which I will take this concept of important properties of means. Okay. So the first one is your AM, GM, HM inequality. Inequality. Now, if, not if, let's say we start with let, not if, let A1, A2, A3, da 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 till AN be positive numbers. Okay, be positive numbers. Okay, such that arithmetic mean of these numbers is A, which is given by A1 plus A2 plus A3 all the way till AN by N. And geometric mean of these numbers is G, which is nothing but product of A1, A2 till AN to the power of 1 by N. And harmonic mean of these numbers is H, which is N upon reciprocal of these quantities. Okay. Then remember, A will always be greater than equal to G, and G will always be greater than equal to H. Okay. This is one of the very, very important inequalities, and almost in 40 to 50% of your inequality based questions, somehow this concept will be involved. Somehow this concept will be involved. Now, what is the proof for this? I'm not going to prove it for any n terms. I'm going to just quickly prove it for 2 terms. Okay. However, you may watch out for several videos available on YouTube where they will give you the proof for n terms also. Okay. There's one involving log. I would request, I'll send that video to you. Don't worry about it. But that proof per se is not very important. Yes, application is important. So we'll talk about it. So let me prove it for 2 terms. So let A and B be positive real quantities. Okay. So if you have to find out for this, it will be A plus B by 2. Okay. G will be under root AB. And H will be 2AB by A plus B. Correct. So what I'm trying to claim that, A plus B by 2 would be greater than equal to under root AB, and under root AB in turn will be greater than equal to 2AB by A plus B. Okay, so how do I prove it? So I'll start with a very simple expression, root A root B minus whole square. Okay, we all know that this is a positive quantity. So if you expand it, you get A plus B minus 2 under root AB, positive quantity. That means A plus B is greater than equal to 2 under root AB. Divide by 2. Since 2 is a positive quantity, it will not affect the inequality sign. And there you go. So you have proved now this part of the question. Okay, so AM is greater than GM. Now, the very same result I will begin with here. Take the 2 on the other side and divide it by a plus b. So 1 is greater than equal to 2 under root ab by a plus b. Now remember here, a and b are both positive quantities. So a plus b will also be positive. So if you're dividing by a plus b, it will not disturb the inequality symbol. Correct? Now multiply both sides with under root ab. Multiply both sides with under root ab. So this will give you under root AB greater than equal to 2AB by A plus B. This actually proves this part of the required inequality. So GM is greater than equal to HM. Is it fine? There's one more proof, which is a geometrical proof. So I'll share that with you also. That's very interesting. So I hope you have noted this down. Done? Okay. So I'll give you a geometrical proof. Can we divide by AB? If it helps, why not? Pranav? Why not? We can divide it by that. Okay. All right. So consider this to be your x-axis. Okay. Consider this to be your x-axis. And let's say, or your real axis. Okay. So why I made the y position? Because I want to show you that I'm picking up two numbers over here, which are positive. Okay. So let's say A and B are two numbers picked up on the positive x-axis. This signifies that your A and B are positive quantities. Okay. Let me make a semicircle over here. Semicircle with AB as the diameter. There you go. Okay. All right. So let me call them by the name of A and B also. Let's say C is the center of this particular semicircle. What do you think is OC distance? What is OC distance? Can anybody tell me? O to A is A. This is A. O to B is B. I want to know what is O to C. A plus B by 2. Absolutely. Absolutely. No doubt about it. It's A plus B by 2. Right? It's the midpoint of the point A and point B. So C is the midpoint of point A and point B. A plus B by 2. Okay. All right. All of you please pay attention. I'm going to do a small construction over here. From O, and let me remove these unwanted terms which I don't want to retain. Yeah. From O, I'm dropping a tangent onto this semicircle. Okay, let's say I call this point as point T. Okay, who will tell me what is OT in terms of small a and small b? In terms of small a and small b, what is OT? Now, for that, you may either use Pythagoras theorem on OCT, because you already know OC distance, and you know this is nothing but B minus A by 2. So you may use Pythagoras theorem, but you may also use a law which you had learned in class 10th. I would like everybody to recall this law. From an external point, if you draw a tangent, and from the same point, if you draw a secant, okay, I don't know how many of you still remember this law. You would know, recall that PT square is PA into PB. How many of you remember this? Childhood days? Yeah, Gayatri remembers. Yeah. So think as if the secant line is your x-axis itself, isn't it? And your OT is your PT over here, right? So your OT square is OA into OB, which is B. So OT will be under root of AB. OT will be under root of AB. You may also use Pythagoras theorem for the same. That will lead to the same result. Don't worry about it. Okay. Now, one more construction I'm going to do. I'm going to drop a perpendicular from T onto the x-axis, and let's call this point M. Okay. Who will tell me what is OM? Who will tell me what is OM? Now, I'm sure most of you would be guessing, sir has already got AM. He has already got GM. So OM should be your HM. But I understand, I appreciate your smartness in that regard. But I would request you to figure it out. What is OM? How did you get OC as A plus B by 2? Okay, if this is point A and this is point B, C is the midpoint of A and B. Correct? That's all. Okay. All right. So for finding OM, let me just discuss a small thing with you. Can I say OMT, the triangle OMT will be similar to triangle OTC? Would you agree with me or not? OMT will be similar to triangle OTC, right? Because this angle is same and one of the angles was right angle. So angle, right? Isn't it? So OM by OT should be equal to OT by OC. Correct? So OM by OT should be equal to OT by OC. That means OT square is OM into OC. Correct? Which means OM is OT square by OC. OT square is AB, remember, because OT was under root AB, and OC was A plus B by 2. A plus B by 2. So it will become 2AB by A plus B, and this result becomes 2AB by A plus B. Any questions? Any questions with respect to the derivation of OM part? Any questions? No questions? Okay. If there's no question, let me bring your attention back to this figure. Right? Do you all agree? Do you all agree? Do you all agree when I say OC will be more than OT? In fact, greater than equal to OT? Pranav, when did I say OM is equal to OT? Did I say that? Or you're talking about this inequality? It can be equal to also. I'll tell you when it is equal. Wait. Okay. First of all, do you all are convinced with this fact that OT will be more than, OC will be more than OT? Because OC is the hypotenuse of OCT. Correct? Now, bear with me when I write equal to. I'll justify it in some time. And can I say OT will be more than equal to OM because OT is the hypotenuse of OTM? Correct? Now, Pranav, the doubt about equal to can be explained by the fact that if I take A and B equal to each other, that means your semicircle collapses to a dot. Then OT, OM, OC will all be equal to each other. Do you realize that? So in that special case where A and B are coincident points, then this semicircle will collapse to a point semicircle. On that point semicircle, try to imagine OT, OC, OM, they will be of the same size. Got the point? That is why equal to is also permitted. So if OC is greater than OT, basically you're trying to say arithmetic mean is greater than equal to geometric mean, and geometric mean is greater than equal to harmonic mean. And yes, a very valid point brought about by Pranav. the equality will hold true. That means the equality holds. Equality holds when the quantities are equal. So here also, let me go back to the previous slide. So when will AM be equal to GM will be equal to HM? When they are all equal. Okay. So let me just go back and make that addition into our theorem so that it is at one place. Yeah. So here, let me write equality holds when A1 is equal to A2 equal to A3 equal to AN. So when all these quantities are equal, arithmetic mean, geometric mean, harmonic mean will be same. Is that fine? This is theorem number 1. We'll come back and take a lot of questions on this, but let me take the other important properties. Okay. So I hope there is no doubt about it. AM, GM inequality, very important, guys. I cannot stress upon how important it is. Okay. Till you start solving questions. Second important property is, let's say, why do I write if? Let A and B be two positive real numbers. Okay. Such that A is the arithmetic mean, G is the geometric mean, and H is the harmonic mean. Okay. How many of you who have studied this chapter before realize that A, G, and H, okay, or H, G, and A themselves are in GP? Did anybody figure this out? That arithmetic mean of two numbers, geometric mean of two numbers, of course positive numbers, and harmonic mean of two numbers themselves are in GP. Yes, they themselves are in GP. Very surprising, you know. That means G square is actually equal to AH. We can prove it. What is G square? G square is AB. What is A into H? A is nothing but A plus B by 2. H is nothing but 2AB by A plus B. So 2 gets cancelled. A plus B gets cancelled. So you get AB again. So what does it mean? It means G square is equal to H. Okay. Okay. So please notice this, what I'm trying to say. Please listen to this, what I'm trying to say. For two numbers A and B which are positive, the arithmetic mean, geometric mean, and harmonic mean, or harmonic mean, geometric mean, arithmetic mean, the order is just reversed. These three numbers themselves will be in GP. Themselves will be in GP. Got it? Now a natural question will arise in your mind. Sir, can I say the same if there were more than two numbers? So let me ask this as a question to you. If there were more than two numbers, something to think. This is a bulb thinking point. So if we have, let's say, A, B, C as positive real numbers, can I say G square? That means, I hope you all know what is G square for this. G will be cube root of ABC, right? Square of that will be G square. Can you say this here? What do you think? Yes? No? In certain cases, yes. For two numbers A and B, it will always be valid. But I'm asking for more than two numbers, will this relation be valid? Okay. Now the answer to this is, it will be true for certain case. Okay. Not for all the case. So this is not true in general, but it will be true for certain case. And what is that case? Let me discuss with you by a simple example. So let's say let's say, consider an example of A, B, C being 1, 2, and 3. Okay. So what is your arithmetic mean? Arithmetic mean will be 1 plus 2 plus 3 by 3, right? Which is 6 by 3, which is 2. Okay. What is the geometric mean? Geometric mean is 1 into 2 into 3, cube root of that, which is cube root of 6, right? And what is harmonic mean? Harmonic mean will be 3 divided by 1 by 1, 1 by 2, 1 by 3. Okay. Let me multiply with a 6 throughout. So it will be 18, 6 plus 3 plus 2, which is 18 by 11. Okay. Now, I do not think so that G square, let me write it. Now, I do not think so that G square is equal to A into H. I do not think so. Okay. So here, this rule doesn't work. So G square is not equal to H, right? But however, let me choose one more example. Let me call this as example number 1. Okay. Let me choose one more example. Example number 2. Let's say this time I take my A as 1, B as 2, and C as 4. Okay. In other words, I've chosen A, B, C themselves in GP. Okay. So in this case, what will be the arithmetic mean? Arithmetic mean will be, if I'm not mistaken, it will be 7 by 3. Geometric mean will be 1 into 2 into 4 cube root, which is actually 2. And harmonic mean will be 3 divided by reciprocal of 1, 2, and 4. Multiply throughout with 4, it will become 4 plus 2 plus 2. 4 plus 2 plus 1, my bad, that is 12 by 7. Okay. Now try doing this. G square, that is actually 2 square. Is it equal to A into H? Is it equal to A into H? The answer is yes, right? That means in this case, G's A and H basically satisfy this condition. So the moral of the story here is, when the quantities involved, right, are themselves in GP, then G square is equal to H will always be satisfied. But if the quantities involved are not in GP, then G square will not be equal to H. Then it will be true for 2 of the quantities. So if I've taken 2 quantities, no matter whatever are those 2 quantities, but they should be positive. For any 2 quantities, G square is equal to H is always satisfied. But if you have more than 2 quantities and you want that condition G square equal to H to be satisfied, then the quantities themselves, right, A, B, C, D, whatever, no matter whatever the number of quantities you are taking, those should be themselves in a geometric progression, right? It's not about C being even, Gayatri, right? They should be in geometric progressions themselves. Is this fine? Why I'm discussing this with you? Because this has come in one of the competitive exams. I think it was JEE main only. Okay. So please make a note of this. Okay. Let me write it down. For A1, A2, A3, ... till AN in GP, remember geometric progression square will be product of A and H. Is it fine? Now, somebody, please try to prove this. Okay, please try to prove this and send me the proof. If you can send me the proof, why it works for this case. Why it works when your quantities themselves are in GP. Why G square is equal to capital H for such cases. Okay. Moving on, one more property we have to take up and then we'll take few questions. Okay. So one more property I would like to take up. The reason for this property is because many questions have come related to it. if let's say A, B, C are positive real numbers such that capital A is the arithmetic mean, capital G is the geometric mean, and capital H is the harmonic mean between the three numbers. Okay, then small a, small b, small c, that is these quantities themselves are roots of x cube minus 3ax square plus 3g cube by h x minus g cube equal to 0. Now, do you have to remember it? Not necessarily. I mean, if you can figure it out in the exam also, if at all a question comes related to it, I don't think so it'll take you much of a time. So let us derive it. Let's prove it. See, if you have an equation whose roots are ABC, okay, so you definitely know that cubic equation, the polynomial equation whose roots are ABC, would look like this, correct? If you simplify it, it becomes x cube minus a plus b plus c x square plus ab plus bc plus cax minus abc equal to 0, right? Now, what is this quantity a plus b plus c? If you see from here, a plus b plus c is actually 3a. So this can be replaced with a 3a. Okay. This already I can see from G here, ABC is actually G cube. So this can be replaced with a G cube. Okay. Now what about this guy? For that, let's come to the H expression. If you see this expression, yeah, it's same as that quadratic one. If you see this expression, H is equal to 3 by AB plus BC plus CA by ABC, correct? So ABC will go up. So ABC will go up and we will have this expression. So from here I can say AB plus BC plus CA is 3ABC by H. That is nothing but 3G cube by H. Okay, so this is nothing but 3G cube by H. Okay, so this proves the required equation is going to be this. Again, no need to remember this, but if you do, you are going to save some time in case a question comes related to it. So this will have roots of A, B, and C. Is this fine? Any questions? So these are some properties, very important properties that we need to keep in our mind. Let's solve questions now. Let us solve questions now. Can I take questions? Should we do questions? Yes, sir. We will do questions. Just a second. All right, let's take questions. The first question that we will solve is this one. If yz, zx, xy add up to give you 12, xyz are positive values, find the greatest value of xyz. Find the greatest value of xyz. Please put your response on the chat box. Very good. I can see responses coming from most of you. Okay, very good. So here, many times when it comes to questions like greatest value, least value, etc., or when you see the words like positive, so these are all like hints for you to use AMGM HM inequality. Correct? So if let's say X, Y, Z are positive quantities, dear students, I would like to reiterate this. I have reiterated this several times in past also, but some students, they don't listen to me, and as a result, they make a lot of mistakes. AMGM HM inequality will only work when you are applying it to positive quantities. AMGM HM inequality, I repeat, that will work only when you are applying it to positive quantities. They will not work if you are applying it to negative quantities. Are you getting my point? So please don't try to apply it everywhere you want. No. Only when you are sure that the quantity you are dealing with are positive, then only go ahead with AMGM HM inequality. Else it is null and void. It doesn't work there. Okay. Now, since X and Y and Z are all positive quantities, their product will also be positive quantities. So this is a positive quantity, this is a positive quantity, and this is a positive quantity. So can I say arithmetic mean of these quantities will always be greater than their geometric mean? So basically I'm multiplying it and taking this, correct? So this is already 12 by 3. This will be greater than equal to, this is x square, y square, z square to the power of 1/3, which is 4 is greater than xyz to the power of 2/3. So xyz is less than equal to 4 raised to the power 3 by 2. And 4 raised to the power 3 by 2, as we all know, it is 8. Okay, which implies that the maximum value or the greatest value of xyz is 8. Greatest value is 8. Is it fine? So those who gave 8 as the answer, absolutely correct. Absolutely correct. Abhinav, Gayatri, Pratik, Hariharan. Aditya, what went wrong? Okay, let's take this. A, B, C are positive quantities, then prove that A by B plus C, B by C plus A, and C by A plus B is greater than equal to 3 by 2. It's a prove that question, but don't be under the impression that this will not come, so I should not pay attention to this. Always remember, prove that questions can always be objectified. Anybody who is done, please say just done. You don't have to give me any kind of a justification. Just say done. Now, the most challenging part of these type of questions is, where should I apply AMGM inequality? Where should I apply, or which terms, on what terms should I apply AMGM HM inequality? That is the part which is most challenging. Everybody knows how to apply it. But लगाना कहाँ है? किन terms पे लगाना है? That we are not able to answer. Right? So on what terms to apply AM, GM, HM inequality? We falter on that front. Okay, Pranav got it. Very good, Pranav. I hope you have got it convincingly. Okay, so let's discuss this. Let us choose the three terms which we are going to apply the AM-GM inequality as 1 by A plus B, 1 by B plus C, and 1 by C plus A. Okay, so can I say AM of these three terms will be greater than equal to the harmonic mean of these three terms? Am I right? Is this correct? So this term divided by 3 is nothing but the arithmetic mean. And 3 divided by reciprocal of these terms. So reciprocal of 1 by A plus B will be A plus B. So this is your harmonic mean. Okay. In other words, what you're trying to say is, 1 by A plus B, 1 by B plus C, and 1 by C plus A is greater than equal to 9 by 2A plus B plus C. Correct? Let's take this A plus B plus C to the left side. So A plus B plus C, and let's keep dividing by, okay, is greater than equal to 9 by 2. Correct? Can I write it as 1 plus C by A plus B? Can I write it as 1 plus A by B plus C? And can I write it as 1 plus B by C plus A? Okay. Take this 1, 1, 1 on the other side, and you are able to show that A plus B, A by B plus C, B by C plus A, and C by A plus B will be greater than 9 by 2 minus 3, which is nothing but greater than 3 by 2, hence proved. Okay, so this term is what we have got over here. Now, this doesn't come overnight. Let me tell you, these are, questions which are asked in Olympiads, mathematical Olympiads. Yeah, Hariharan, coincidentally, you also asked the same thing. So they are very difficult. A lot of times you will do some trial and error and will not work. Okay, so please practice a lot of questions of these types from whichever book you are practicing. I think there are a lot of questions. I think there's an exercise on Cengage which is completely based on AMGM inequality. It is there in one of the drives. I shared with you one of the drives with a lot of books in it. Okay, so in that, I think chapter number 3 or 4, I'm not very sure. Just solve a lot of questions from there. Okay, all right. We'll take one more question on this. Can I go on to the next page? If at all you have copied this. Should we take another question? All right. Let's have another one. Yeah. Put my camera down. Yeah. Prove that NC1, NC2 square, NC3 cube, and so on till NCn to the power of n is less than equal to 2 to the power n by n plus 1 whole raised to the power n plus 1 C2. This is your n plus 1 C2. If you are not able to see this, I'm just going to write it again. N plus 1 C2. Okay. In other words, what you're trying to show that C1, C2 square, C3 cube, and so on till Cn to the power n is less than equal to 2 to the power n, n plus 1 whole raised to the power n plus 1 C2. For the purpose of, you can write 1 here. Just say done if you are done with it, or at least think about it for 1 minute how to solve it. Yeah, these are binomial terms. These are binomial coefficients. Yes, absolutely. Any idea? Okay, all of you please have a good look at it. You have multiplied C1 to the power 1. You have multiplied two C2s actually. Okay, Aditya, fine. So basically what I wanted to show you that this guy was C1, C2, C2, C3, 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 like that. And this Cn guy was Cn, 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 n times. 3 times. 2 times. This should ring a bell actually. And they are multiplied, so something related to their geometric means is happening. Correct? Yes, Pranav, absolutely. Yeah, correct. Okay. All right. So if you are having this kind of a term, so let us start with this fact that there is one C1, there is two C2s, there are three C3s, there are four C4s, there are five C5. Oh, sorry. There are five C5s and so on, and there are NCNs. Okay. Now, if let's say I take these quantities and treat them as our quantities, let us find out the arithmetic mean of these quantities. So what will be the arithmetic mean? So it's just a simple arithmetic mean will be the sum of these. So now remember, since there are two C2s, I can write twice of C2. There are three C3s, I can write 3 times C3, 4 times C4, till n times Cn. Okay. By how many total quantities will be there? 1 plus 2 plus 3 till n, which is nothing but n into n plus 1 by 2. Do you agree with this or not? Do you agree with this or not? Yeah. Now, what will be the geometric mean? Geometric mean is when you multiply them all, C1, C2, C2 multiplied will be C2 square, C3, C3, C3 multiplied will be C3 cube, Cn to the power n, whole raised to the power 1 by n plus 1 by 2. So 2 will go up. Correct? Correct. Now let us use AM greater than equal to GM inequality, right? But before I move on, I would like to ask you, go back to a few weeks ago class and tell me, do you recognize this gentleman? Do you recognize this guy? If yes, what was the answer to this? Yes. If you don't remember it, no worries. You can quickly derive it also. So for this, I'll just like to take you back to your binomial theorem chapter, where we had studied that in order to derive such kind of an expression, we used to differentiate this guy, isn't it? So let's differentiate with respect to x. So it will be n 1 plus x to the power n minus 1. Here you will get c1, 2, 2c2x, 3c3 x square, and so on till n cn x to the power n minus 1. Put x as 1, you get n into 2 to the power n minus 1 as c1, 2c2, 3c3 till n cn, right? So this fellow that you see on the numerator is actually 2 to the power n into 2 to the power n minus 1. Okay, so this fellow is n into 2 to the power n minus 1. Okay, so let's use that result. So n 2 to the power n minus 1 upon n plus 1 by 2. So 2 will go up. This will be greater than equal to C1 C2 square C3 cube Cn to the power n whole to the power 2 by n plus 1. Okay. Now a lot of terms will get cancelled. This will get cancelled. 2 into 2 will become 2 to the power of n. And let us bring this term as a term on the other side, whole raised to the power n plus 1 by 2. So guys and girls, we are almost done with the question. This term will be less than 2 to the power n plus 1. And I would just like to bring your notice to the fact that this term is actually n plus 1 C2. Try it out. Henceforth. Is this fine? Any questions? Any questions? Any concerns? Do let me know. Nice question, no? And you can always objectify it, right? They can always objectify it. Please copy it out, copy it down so that we can move on to our next concept.